Good afternoon. We are starting our new unit today, which is on vectors. There we go. So vectors, we're going to have a little bit of difficulty because I can't draw. I mean, I can draw, but it's going to be hard for me to see you draw and everything. We're still going to learn vectors. We just may not go quite as in depth. We'll see. We'll see how it pans out over the next week or so. So vectors, some of you may have had this in physics already. But I'm going to kind of assume that most of you have not, even if you have. And so I'm going to teach it just like, it's brand new material. So vectors have two components. They have a magnitude and a direction. So magnitude is just a fancy word for length. Okay? So it may be 5 centimeters, it may be, 2 units, and we don't know what that is. We might be 154 miles. It totally depends on the type of problem. And then direction can be north, south, east, and west, or, a variation of those. It can be right or left. It can be up and down. You can just point. Or what we're going to do is we're going to use degrees. So 30 degrees, we could draw it something like that. We could say 300 degrees, which would be something like that. Degrees is something that we're used to, and we're used to doing right triangle trig. And so that's what we're going to stick with as we work with vectors. Okay, so today we're going to look at 3 vocabulary words. We're going to look at component form, magnitude, and direction. Okay, so the first thing is, here are all my vectors. Oh, I didn't say that before. A vector is going to typically look like a ray. Okay, so you could say this looks like it may be something like 5 centimeters. I just made that up. And maybe it's about 60 degrees. Okay, or we could do this vector. That could be 2 inches. And we could say it's pointing south. That's one thing you could say. Or we could say it's 270 degrees, because here's where we start. 270 goes like that. Or we could say negative 90 degrees if we wanted to go that way. So anyways, vectors will look like rays. So we have a bunch of rays over here. In order to do these problems, the best and easiest thing we should do is probably go ahead and make individual graphs for each of these. So we're going to make an X and Y axis for all of these at that starting point, so it's right at our origin. Okay, so that's what I'm doing really quickly. You can envision these sides going out further to the right and to the left, but I'm just trying to kind of make that bullseye right there on the starting or initial point. Okay, so let's start with component form. Component form looks like pointy parentheses, and it's basically your X direction and then your Y direction. Okay, I'm going to start with U, and then I'm going to go to V. I think you'll see why in just a minute. Okay. All right, so I'm going to start with U, and my component form means I want to figure out how far it goes to the right and up. In this case, it does go right and up, but it might go left and down or left and up. It depends on what quadrant it's in. If you look at U, this is definitely in quadrant 1, so both our X and our Y should be positive. Okay, so I'm going to draw a right triangle, and then this should help me. Okay, so how long is this side? It is 1, 2, 3, 4, 5, 6, 7. It is 8 units long. And then this one is 1 unit long. So there is my component form. I went 8 to go from the starting point to the stopping point. I went 8 units to the right and 1 unit up. Okay, so my component form is 8, 1. All right, now magnitude is how long is this vector U. So basically, I want to figure out the length of this right here. Well, if I have a right triangle, I can just find the hypotenuse, and that is the magnitude. So if you notice here, we've already done component form. So if we look here at magnitude, it's essentially just the Pythagorean theorem. We've gone ahead and taken the square root of it. You will see for magnitude, you might have bars that kind of look like absolute value bars, but they're not. And you might see a set of double bars. So just know that the bars or the double bars mean magnitude. And so really all you have to do is take the components and square them. So that's 64 plus 1, which is 65. And there it is. Now, some of you might be saying, well, what is the square root of 65? Well, we know that the square root of 64 is 8, so it's just a little more than 8 units. Precisely, it's like 8 point, I think it's 0.6. Let's look. I'm just going to type it into my calculator. Yep, I was right, 8.06. Now, we're going to leave it in this form, the radical form, because this is just an approximation. So we don't want to actually leave it like that. I just wanted you to know that it's a little more than 8 units. Okay, so we have our component form. We have our magnitude. That's how long it is, about 8, a little more than 8 units long. And then now we want to find the direction. Now, we're going to do this in degrees. So you guys, if you look at this, it is definitely in quadrant 1. And it is really small, okay? So if we were to draw our angle, it's like here. There's our theta prime. Gosh, that looks like a colored in circle, sorry. Let's use theta prime. Okay. Is this angle right here, sorry. Trying to make it clear. All right, so we should expect a very, very, very small angle. All right, so let's do the math and see what happens here. All right, this says to find direction, we're always going to use sine. And in sine, SOHCAHTOA, sine is O and H. Okay, so we're going to use the O side and the H side. And then depending on the quadrants, we may have to do a little bit more work. I'll show you that as we go. Okay, but I just wanted to have these notes here gone ahead and written out for you. Okay, so we're going to do sine of theta, and so we're going to use the O side, which our opposite side is 1, and our H side is what we just found, and we found it to be root 65. And now we're going to type that in. All right, so we're going to type in, and y'all, if we're finding an angle, we have to type in second sine, or if you use Desmos, remember how to do that. 1 divided by square root of 65, and then you just have 2 parentheses to close. You get theta prime is approximately, what does it say? It says round to the nearest tenth for magnitude. We're not going to. We're going to leave it in, and then to the nearest degree. All right, so the nearest degree would be, let's do tenths just to be 7.1 degrees. Now, does that make sense? Does this look like it's about 7 degrees? The answer is yes, it's very small. So there's our answer. The magnitude of this vector is root 65 units, and the direction is 7.1 degrees. All right, let's do another one with U. Now, U should be a little bit trickier because it is not in quadrant 1. Okay, that's why I picked U to do first, because it's in quadrant 1. Now, V is not in quadrant 1. So we should automatically think our angle should be between 270, which is here, and 360 degrees, which is here, right? So it should be somewhere between those two. Now, let's go ahead and draw our right triangle. Do you remember our right triangle always needs to be drawn to the x-axis? So we're going to go from here, here, and then back over. Okay, and now we can come up with our components. So let's count the sides. 1, 2, 3 units, and this one is 1, 2, 3, 4, 5 units. Now, when you write it in component form, well, actually, let's be a little more clear here. We want to go x and then y. Okay, so x, we're going to the right, 1, 2, 3 units, and then we're going down. So that 5 really should be negative. Okay? So our component form for V is 3, negative 5. Because we want somebody to look at this component and tell me, okay, 3, negative 5 means you're going to the right 3 and then you're going down 5. And that's how you draw your vector. Okay? Oops. Okay, so now let's do Pythagorean theorem with those values. So the magnitude of v is going to be the square root of 3 squared plus negative 5 squared. Okay, so that's going to be 9 plus 25, which equals the square root of 34. And then you're going to try to break it down if you can. 34 does not break down, so that's our final answer. If it breaks down, we want to simplify our radical because we're good at that, okay? All right, now we're going to use this right triangle to find our theta prime. Now, I'm going to be really clear about this. This is just theta prime. It's not going to be your final answer. You will always get an acute angle. It's called a reference angle. So that acute angle will then help us find the actual angle that goes like this all the way around, which is what we're trying to find, okay? So we're still going to do sine. So sine of theta prime equals, our opposite is going to be the y value always. If you notice, it was here it was 1, which is our y value. Here it's negative 5, which is our y value. And y'all should know that because sine always corresponds with y. And then our hypotenuse, or the number that we just found. So you see, it's really important to make sure you get that magnitude correct. Okay? And now I'm just going to type that into the calculator. Second sine, or inverse sine, negative 5 divided by root 34. Now, you're going to get a negative answer. You just have to take the absolute value. Okay? And I'm going to put approximately, and I'm rounding to the tenths, but it was 59.03, so it's just going to stay 59. Now, you should tell me right now that does that make sense for this problem? The answer should be no, because 50-something degrees is up here, right? Now, this angle that we just found right here is actually 50 degrees, but we have to understand how that helps us find the full angle. And so that is where this stuff comes into play, okay? In quadrant 1, like we saw in this problem V, you had to do no extra work. Once you found the angle, you were done. But now here, where does this vector V fall? It falls in quadrant 4. So we're going to be doing this rule right here. So we're going to take our angle that we just found and we're going to subtract it from 360. See the formula? To find your angle, you're going to do 360 minus theta prime. Okay, so we're going to do 360 minus 59 degrees, which gives us, I'm just going to put equals. All right, so 360 minus 59 gives us 301 degrees. Now, does that make more sense to the picture here? The answer should be yes, because remember, initially I said our answer needs to be between 270 and 360 over here. And that definitely makes a lot of sense. Okay? So just know that when you find your angle, sometimes you have to do a little bit more work before you're done. Okay? So if it's in quadrant 1, you have to do no new work. If it's in quadrant 2, you take the angle and subtract it from 180. If it's in quadrant 3, you take the angle and you add it to 180. And then if it's in quadrant 4, you take the angle that you find and subtract it from 360. Okay, and you will be doing that with H, K, and W. Okay, no, I lied. Not H, because do y'all see H is in quadrant 1. But K, you're going to have to do a little work because it's in quadrant 3. And W, you'll have to do a little work because it's in quadrant 2. Okay, so I want you to try those. Now, I'm going to talk about R because R is a little bit funky. It's almost so easy it seems difficult. So R is a special case when we come up with component form, because can you draw a right triangle with this if it's perfectly vertical? And the answer is no. So our component form is from this point to this point, we're going to go over to the right and to the left, none. So our X component is going to be 0. Okay, does that make sense? And then we go up 1, 2, 3, 4, 5 units. So our Y value is 5. Now, we could do magnitude of R with Pythagorean theorem. I'll show you. 0 squared plus 5 squared. So 0 squared is 0, 5 squared is 25, so that'll give me the square root of 25. Well, the square root of 25 is 5, right? So there's my magnitude. Now, you could have just said that from the beginning. A length is easy to count if it's perfectly vertical or horizontal. See? 5 units right there. We could have counted it like that. We don't actually have to have Pythagorean theorem, okay? I could also do the same thing if I had a vector going like this. How long is that vector? Well, it's just 2 units, so it's -2 units long, or 2 units long because you have to take the absolute value. But so what I'm saying is if you have something that's perfectly vertical or perfectly horizontal, you don't actually have to do the Pythagorean theorem. You can just count, okay? But as you see here, Pythagorean theorem still does work. Now, what about the direction? How many degrees is this guy right here? Well, if it is perfectly vertical and it's perfectly, going straight up north, how many degrees does it open up from standard position? Well, y'all should know that. That opens perfectly to 90 degrees. So we do not have to do any work. We can just state that, okay? So there you go. I want you to try H, K, and W to find you may have to draw this on your own paper, scratch paper to kind of figure out the components. I'll zoom in again, but you're going to write the component form, then you're going to do the magnitude, and then you're going to come up with the direction. I'm going to put a star by this one because remember that means you may have to do a little bit like a second step after you find the angle, which you will on 2 of them. Okay, so good luck. Here are those again, and I'll try to attach the PDF as well so you can print it out if you want to. Okay, awesome.